Hello and good afternoon, CSI157 Section 841 students at Anne Arundel Community College. This PacketTracer tutorial is going to go over PacketTracer 8.4.1.2, which is going to challenge you with some IPv4 and IPv6 addressing tasks. Alright, so let's jump right in. We can read through the scenario, and basically you have a set of requirements that you're going to have to meet. The first is to complete the addressing table documentation. And from looking at the addressing table documentation, you can see that the default gateway is going to be the information that we would need to provide. The first is to configure R1 with IPv4 and IPv6 addressing. So let's go ahead and pull up router R1. And I'll slide it over here so we can see what's going on. So I'm going to go from user exec mode into privilege exec mode, from privilege exec mode into global config mode, and then from global configuration mode into interface configuration mode, and we're going to configure interface gigabit Ethernet 00 first. So the first thing we want to do is we want to bring the interface up to ensure that we don't forget to bring it up once we're done completing our IPv4 and IPv6 configuration tasks. The next thing that we're going to do is we're going to do the IPv4 addressing with the IP address 172.16.10.1 with a /26 subnet of 255.255.255.192. And again, the key thing to remember, this is a Class B address, and that will not change. This will always be a Class B address. It simply has a Class C subnet mask applied. And so we'll hit enter. We're also going to put our IPv6 information on here. So IPv6 address for gigabit 00 is 2001:db8:cafe:1:1/64. And we also want to put our IPv6 link local address on here. And this is going to be the address that any IPv6 queries will be looking at for their default gateway address. And so the IPv6 link local address is going to be FE80::1, and if you do the question mark here, you're going to go ahead and establish that as the link local address. And again, remember that the link local address is locally significant, which means it's only significant on this subnet. Alright, so we'll enter that in, because you'll notice in a second here we're going to enter in that exact same link local address on the exact same router, simply on a different interface that's servicing a different IP subnet. Alright, so we have all of our information entered in here. Now let's go ahead, we'll exit out, we'll go back into gigabit Ethernet interface 0/1. We'll bring our interface up, and then we'll put our IPv4 address on here, which is going to be 172.16.10.65. And again, in keeping with the /26, 255.255.255.192. We can put our IPv6 address on here as well, and this is going to be 2001:db8:cafe:, and this is going to be 2, again, different subnet. And if you remember from the reading from chapter 9, with IPv6 addresses, there are the 16 bits, whoops, excuse me, let me cancel that. There are the 16 bits after the first 48 bits where the subnetting information is put in. And you'll remember that we can drop the leading zeros. So this field here should actually be 0001, right? And that's our first subnet from this address range. And now we're basically saying this is going to be 0002. And if you remember walking through, if I wanted to do another subnet, it would be 000, and then we'd have the 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F, and so on. And again, subnetting an IPv6 is not so much so that we can right-size our networks or to conserve IP addressing space. Remember, the critical task with subnetting an IPv6 revolves around coming up with a logical subnetting strategy. And so here we're going to use 1, 2, and then if we had another interface it'd be 3 to keep things in a logical order. Alright, so back to our IPv6 address on gigabit Ethernet 0/1. So it's cafe:2::, and 1/64, and we're going to go ahead and put the IPv6 link local address of FE80::1. And again, if you do your question mark, you can establish that as the link local. So as you can see, we've applied or assigned FE80::1 to two interfaces on the same router. But keep in mind that they are locally significant to the subnet in which they are a member, right? Okay, so we've already done a no shut on the interface. Everything has been established here, so I'm going to type end. We're going to do a write mem, and then let me go ahead and close this guy down. And as you can see, we've got green links all around. So switch 2 is already configured according to our next requirement, and it says configure switch 1. So it never hurts to take a look at the configuration of the switch or the component, if you can, that they say is already configured, because it could give us some clues as to what we need to do. As you can see here, interface VLAN 1 has been configured with .126, and so that corresponds to the information we see here. It's a /26, and that would be the default gateway. So let's take a look, and sure enough, the IP default gateway command has been run. So if I'm on switch 1, I'll pull switch 1 down over here. We'll take a look at the CLI on switch 1. We want to go ahead and go from user exec into privilege exec. Whoops. From privilege exec into global config mode. And then we're going to go into interface VLAN 1 or interface configuration mode. So from here, I want to bring my interface up right away so I don't forget. And then I'm going to assign the IPv4 address, because that's really the only task that we have. So it's 172.16.10.62 is our IP here. And again, 255.255.255.192. And so that's done. So I'll exit out of interface configuration mode, moving into global config mode, where I'm going to enter in the IP default gateway command, because I want to make sure, and this is key to remember, the IP default gateway command is not for traffic on the data plane per se, or traffic that's transiting the switch from our hosts. The IP default gateway command is actually placed on the switch to provide a default gateway for traffic that is generated by the switch. So if I'm pinging from this switch, which I will be in a moment, that's the traffic that relies upon this IP default gateway command. It's not, let's say, manager A or accounting.pka that needs to see a default gateway here, because remember, on these guys, our default gateway is set, and we'll set those in a second, and the default gateway on the hosts points to this gig00 interface on the router. So again, when you're using the IP default gateway command for the switch, that command is entered in there for traffic that's being generated by the switch. So if I was running a ping command or a traceroute command from the switch, that's what requires this IP default gateway command. So let's get that entered in here. 172.16.10.1 is our default gateway on this subnet. All right, so then let me save my config. Okay, and let's shut this down here. We'll shut that guy down and shut this guy down. Okay, so then configure manager A. So the same thing, if manager B is already configured, and we'll put manager B over here, there's no harm in taking a look at manager B's settings to see what they show. So we'll look at our desktop here. All right, so I'm going to configure manager A is going to be 172.16.10.3. And my subnet mask, again, as you can see, it's going to automatically populate the subnet mask field, at least in PacketTracer, with the default subnet mask for a Class B address. So again, remember, the class of the address is never going to change. And it's the first octet value that determines what class of an address you're going to have. So 172, which falls between 128 and 191, would be a Class B. And therefore, it automatically populates this with the Class B subnet mask. But we know that we're applying to the Class B address, we are applying a Class C subnet mask, a /26. And we've entered that information in there. And so now we have our default gateway on our side is 172.16.10.1. And the DNS server will be 172.16.10.66. All right, very important that we get our IPv6 information in here. So it's going to be 2001:DB8:cafe colon, and on our side over here it's 1 colon colon 3. And you can think of it as the IP address which ends in .3. We're trying to stick with that configuration notation here. It's a /64, right? Okay, now the link local address, that will be automatically generated for us based off of a random algorithm that the operating system will use, our default gateway. And this is the link local address that we entered in on the router interfaces. Remember on gig 00 and gig 01, we entered in FE80 colon colon 1. So our IPv6 gateway is going to be that FE80 colon colon 1 address, that very same address that we entered in on both interfaces, keeping in mind, again, that that is locally significant. So we can take the DB8 colon cafe colon 2 colon colon 2, which is going to be the IPv6 DNS server. And again, we're leaving this link local address field blank, right? Because this is going to auto-populate for us. So I'm done with Manager A, so I'll close that out here. Let's close out Manager B's settings. Now if I come in here and I type ipconfig-all, it's going to give me a listing of all of the settings on the Ethernet interface, Fast Ethernet 0. And as you can see, that link local IPv6 address, that field which we left blank, has now been auto-populated, right? And again, with Windows XP, it would use the MAC address of the system to calculate that setting. However, here, with the newer version of Windows, it's basically picking random values that are slightly based off of the MAC address. But there was a very set way to do it with Windows XP. Okay, so the key is that field is going to auto-populate. So if I were to close this and go back over here, you can see right here it has filled in the value for link local address. Okay, so at this point, let me go ahead and try to ping all the way across to Manager B, who's 172.16.10.67. And as we would expect, we should drop the first ping, at a minimum the first ping, and then the rest of our requests should work, and there we go. Let's try to ping 66, which is the website. Let's see if that works. Again, we would anticipate that we would drop that first ping and then the subsequent pings would work. Okay, and let's try to ping something else on that on that side of the network, and we can ping across to the switch. How about 126? Let's see if we can ping the switch. So I'll ping 172.16.10.126, and the first request times out, and then let's see what happens. We may have to go back and take a look at the switch. The second request times out, and there we go. So we're good. Okay, now let's take it a step further. Let's go ahead and run our connectivity tests, but this time let's ping some IPv6 addresses. So we'll do DB8 colon cafe colon, and everything on the right-hand side of our diagram is within the IPv6 language is going to be part of that subnet to that 16 bits, that hextet that sits right in here after the first 48 bits, where we determine the subnet. And so we've used subnet number 2 here. We use subnet number 1 on the left-hand side of our network diagram. All right, so cafe, and we're going to go 2 colon. And so let's start out with, 2 colon colon 1. Let's start out by pinging the router 1 interface that is over on the subnet 2 side. All right, so we've got success there. So now that we can ping that interface, let's try to ping the the Manager B IP, IPv6 IP, which is colon colon 3. All right, we can ping that. It works like a champ. And finally, let's check out the website PKA, which is colon colon 2. And we can ping through there, and that works great. So let's close this guy down. We'll pull up Manager B. And let's go ahead and try the same tasks on Manager B. So can I ping across and hit 172.16.10.1? I can. That's the gig 00 interface on router 1. Can I ping 10.62, which is going to be switch number 1's IP address? And as we would anticipate here, we're probably going to drop at least 1, possibly 2 packets before we receive our responses back. And there it is. And so now if I ran that again, as we would expect, it functions immediately right away. And then finally, let's ping manager A, and manager A's IP is 10.3. And there we go, and that's working great. Let's try some IPv6 addresses. So 2001:db8:cafe, and we're using subnet 1, and I'm going to ping the IPv6 address of, and did I mistype that there? Oh, I sure did. I said 2000, I put 200. All right, so there we go. So now, unless I've got another typo in here, let me see real quick. So we're going to, 2001, I apologize. All right, there we go. So 2001 db8 cafe :1:1. All right. So there we go. Works like a champ. If you get destination host unreachable, chances are either the host is down or something's wrong or you've got a typo. Okay, so we can ping that IPv6 address on router 1. Can I ping through to the manager A IPv6 address, which would be :3? I can. Works great. And now let's check the IPv6 address of the accounting server, which will be :2, and everything works great. All right, so the last connectivity we need to check here is in our web browser, and we're going to go to accounting.pka. And as you can see, the accounting server works, right? We've got copyrights. There we go. So we're good there. And now let's change this, and we're going to go to, let me double check this real quick. And we're going to go to website.pka. And there we go, the Three Restaurants website. All right, copyrights. Okay, so we have all of our configuration information in there. And again, let's do a quick review here on router 1. I'm going to go from user exec into privilege exec, from privilege exec into global config. I can type exit to get out of global config to go back into privilege exec. Write mem is going to save my configuration so that if I were to reload this device, and let's reload this really quick since it takes place much faster than a real Cisco router would reboot. This is a much abbreviated reboot, if you will, or reload of the router. As you can see, we're already back up. So I'll go from user exec to privilege exec, and let's do a show run and make sure that all of our information has been maintained. And as you can see, here's our interface gigabit Ethernet 00 and 01, still with all of the same information they previously had. And so let me go ahead and close this window out, and let's check our results. Let's make sure that we've hit every item, and we should, because connectivity tests were working fine, right? So there we go. I don't think anything's there. No, there'll be nothing under connectivity tests. And so again, we've scored a perfect 80 out of 80. We've completed all 24 tasks that were required, and in just under about 15 minutes. Okay, so again, this has been PacketTracer Activity 8.4.1.2 for the Spring 2014 students at Anne Arundel Community College in CSI 157 Section 841. I hope everyone's found this educational as well as beneficial to your studies, and I will see you all tomorrow evening. Enjoy the rest of your weekend.